Welcome to Almost Here, Round the Corner Future Technology podcast with Richard Jacobs. Future technologies poised to transform our lives for better or worse are the focus of this podcast. Almost here means these technologies are now here and starting to be used, or just around the corner, from Bitcoin to artificial intelligence, 3D printing, blockchain, virtual reality, and more.
Hello, this is Richard Jacobs with the Future Tech Podcast. My guest today is Ravi Sahu. He's the founder and CEO of Strayos, Strayos, and that's the website too, Strayos.com. Ravi, how are you doing today?
Hi, Richard. I'm doing very well. How are you doing?
Good. Yeah, I'm interested to talk to you about your computer vision work with mining. So, if you don't mind, let us know, what does Strayos do? What's the premise of the company?
Absolutely. So Strayos is a 3D computer vision and machine learning platform for mining industry. And more especially what we are doing in this industry to help is to optimize drilling and blasting operation that happens on a daily basis by using drone images or any camera images and the sensor data that is collected by utilizing drill machines. So we make it easy for the drilling and blasting users to generate, collect data, analyze it, and then use it to make effective drilling decisions.
What kind of things happen in drilling and mining and blasting that cause inefficiencies or problems, or what happens, what goes wrong?
Yeah, that's very kind of one of the core problem that our platform is solving is mining is a very cost-sensitive business. As you know, they can only innovate and improve more on the profit on the margins by reducing their cost, right? And the more better data they have, the more analytics that they have, they improve on those cost metrics they have. So one of the things that they are looking to improve is how effectively they can drill. So which means if they identify an area where they have to generate a raw material, which is practically happens on a daily basis. So what they are looking is to generate an optimal amount of rock size. And to do that, you need to have a very accurate drilling. And then once the drilling is done, you need a proper amount of energy distribution, which is basically placement of explosives to push that wall and to push those material and blast it out. And that requires a lot of just basically understanding of calculations, what's there as a part of the geometry of that particular area, what the geotechnical attributes are there. If they have those decisions before they actually start putting machine to start drilling, if they have those data points, they can make very effective decisions about that area, that how much amount of diameter will be required, how deeper it needs to be drilled, how much amount of material is there in each drilled hole, and then how much amount of actual rock is going to come out when they would do the blast. So all these factors help them to not only reduce the cost, but also improve the safety, because they're not putting a person in harm's way now. Otherwise, in traditional ways, what they're literally doing is a person is going up and down the high wall cliff, and they are collecting data by laser scanners. And that requires, it's a very time-consuming process, and you're always putting a person in harm's way. Now, if you have automated way of doing the data collection and the analysis, you're saving basically a lot more on the cost side, but also improving the safety.
Yeah, that makes a lot of sense. How often do you observe when you're doing drilling or exploding that the movement of rock will not happen immediately, but will slowly happen over a period of seconds or minutes or hours, and what you thought maybe looked okay now is changing or splintering or cracking and causing a potential hazard?
Yeah. So it's mining and this operational activity, which is basically drilling and blasting, is a very frequent activity. And the way we see the mining is a moving factory, right? Where there is a constant change happening in that mining site. So that's why we define it as a moving factory. And the way we look into the aspect of this mining attributes is why how often they need to do is based on how often, what's their goal for the production. So there are about 14,000 open surface mines are there in US only. And these are very, some are small size, some are big size. But really what they're doing on a daily basis is, if they are looking to generate 1 million tons of material, and it could be, a material local, state-wise, they are looking to supply them for building infrastructure, building roads, construction materials. That's how the demand is being created. So if a site, a mining site, is looking to generate 1 million tons of material per month, they would do at least 6 or 7 times drilling and blasting per day, and that goes for like 6 days a week. So it's a very high frequency item, and a lot of And one of the things that we have noticed is mining industry is going through a shortage of skilled labor or just labor in general. And one of the ways that they are looking to address this problem is through automation, data analytics, much more faster, production through improved decision making by utilizing, job site automation or the data analytics in general. So that's where we fit into their value chain and also the solutions that they are looking.
All right. So what's is this in use in various operations? This computer vision applications. And what are you seeing are the benefits or the differences by using it?
Yeah. In case of the drilling and blasting, when we look into that, the usability in this industry, we have about 240 sites where our platform is operational. The biggest benefit to the computer vision they get is not only they are able to get the very accurate data, but they can also look into the other types of ancillary benefits, which is environmental aspects. Right. So every time a blast happens, they have to report to the local. Basically, they have to maintain a document or compliance for the local, local government or local municipality. And that's one of the areas that also they can use the computer vision data is identifying if any activity has happened after the blast. So one of the things that usually our product provides in a more automated ways after the blast happens, whether these explosives which was used in the site, if there is any leakage was there, or if this emulsions, right, whether that has been spread in the site or not. So quickly detect those and let the site manager know where are the areas where the potential the leakages is happening. So earlier they used to walk and inspect. Now, before not sending a person there, in harm's way, and then you can easily detect before you send a crew to inspect that. So these are the ancillary benefits, that they get through the computer vision, and overall, the applications are pretty global. So we've been currently operational in about 8 countries.
Well, what are some things that you're noticing that are surprising or interesting or useful?
From when we started our company, and we thought, the drilling and blasting is one of the use cases that we want to target where lots of problems are there. But as we continue in this journey of understanding the problems from the user's perspective, and building the product as well as making it usable in the site, one of the things that we have noticed is the problem is not only at the production level, but also after the material is produced, there is other sorts of problems are there. So that becomes, perspective for us, when you ask me, what are the other interesting things that, we see that, we have not thought of or it's useful is after the material is generated, mining industry spend about 40% of their cost on the transportation of these materials. And what we see is the production plays a heavy role. How the production has been carried out, it impacts the downstream transportation supply chain. So now what we are doing is, if we can really predict after the blast happens, we are essentially moving a piece of the earth, right? You have basically cut out a piece of the earth, and now you have to redesign your ramp. You have to redesign your roads to, move the trucks in to clear those material, or to have the bulldozers or loading and hauling trucks move those piece of the material that's been carried out. But through our, we can.
Have you seen anyone that does predictive blasting, where they blast in such a way that it'll actually be beneficial to clear it, or it'll be easier to clear it than just blasting and saying, "Oh look, here's this went all over the place. Now we got to clean it up."
Yeah, and that's a really great question, because one of the metrics that we aspire for, is not only a distributed or balanced rock size, but how the loading and hauling gets impacted if you are moving that material through the haul trucks. So if you're blasting a certain piece of the mining site and you're generating material, you want to optimize in certain way that your transportation cost is also less. So loading and hauling, it's a lot of cost effective, needs to be cost effective in such a way that when you are moving out, it has less fuel cost, because if you are loading the larger boulder rocks, if it's not balanced or if not so refined, then you are basically not utilizing your haul trucks in an effective way. Also, if your road grades, if you have designed the ramp in such a way that it's not effective, then you're again putting a lot of pressure on your trucks. And these trucks burn a lot of fuel in one day. And also it has adverse impacts on the tires. So that's the reason when we say how this production impacts the transportation, that's where we are tying back the data now from the production to the transportation to control. If we do the production better, the drilling and blasting, you can optimize on the transportation as well.
What about for drilling? I would think that if you have computer vision and the cameras are mounted right near the pit, and as you're drilling through rock, if you're observing the changes in the rock, the movement of veins, the different nature of the rock as you drill, you could adapt your drilling as well, because that's more of a continuous process.
Yeah, you hit the right point there, because that's exactly what we do is, so first, our platform provides through machine learning, based on the geometry and the geotechnical attributes of the high wall or the mining area, that this is what the suggested pattern is. This is what your number of drilled holes is required. And this is what the depth should be, and this much number of points you should be drilling. And that data gets wirelessly transmitted to drill machines. So we have integrated our software to OEMs, drill OEMs, and once they start drilling, through the designed reports that we produce, we can real time see they are drilling, how they are drilling. So, and now we can see at the Strayos platform what's the deviation happening. So you can quickly course correct if there is any inaccuracies are happening there, or if there is any undetected, structure is there as you are drilling, so that you can course correct and tweak. And that's where the real optimization comes in, because and this drilling, this drilled bits, they have a sensor, so it can detect other attributes like hardness and softness. And as you keep drilling, a lot of the structures gets changed, right? Some may have different composition of materials altogether, like granite, limestone, and so those information gets instantly recorded in the software. And that's where bringing the greater optimization for the drilling. And once the drilling is right, a lot of the other factors gets right then on the blasting side.
What is the computer vision looking at? Is it look? Can it tell like mineral content, or what can it tell? What are you looking at? What do you see?
Yeah, the computer vision part becomes handy here in the understanding of once the either through the collection through the mounted cameras in the conveyor belt or the drill machines. All we are getting is the terrain data, and then processing that terrain data to understand what's the fracture is. Like, if your wall have any high wall fracture data is there, what's the geometry is there. And then we generate a 3D model for that. And once the 3D model is generated, we apply machine learning on that area is what's the weak spots and what's the strong spots in this bench is, or the high wall is, right? Or if you have a ramp there, whether when you're blasting this certain piece of the high wall, this rock will fly into certain direction, correct? Whether that will fly to a ramp area or whether that will fly into a floor area. So all those type of analysis, we are doing through the computer vision.
How fast is the computer vision? Is it processed in real time, or is it a delay where you have to wait?
Yeah, so our computer vision engine that we have is usually depends upon the basically the size of the data set. And these data sets are constantly evolving, right? So if we have about 500 images, usually roughly it takes about 2 hours. So it is not real time because it's a lot of geometrical attributes also gets fed in. So it's just not about the detection or segmentation. So usually for less than 100 images, it's about 30 minutes. User can get the data and get up and running. But as the data size increases, the time also increases in the computation as well.
What do you wish the systems could do that they can't do right now?
One of the things, if I understood your question right, you said what are the other systems they can do that we can't do right now?
Yeah, you want the systems to improve and evolve and get faster and better. So what are some of the things you wish that the software could do but it can't do right now?
Oh, gotcha. Okay. Definitely real time. Real time, that's where we want to go. Improve, bringing the processing at the edge. That's our goal, where the user is feeding the data and they are getting the results instantly as they are feeding the data. So processing at the edge, that's where, and it has certain dependency on the network improvement of the data processing capabilities as well. And in the mining areas, as we know that these are all very remote sites, so they don't have that great connectivity. So that's one of the things. If the connectivity itself can be improved, it will be easier to bring the edge processing. So the more and more the adoption, as we are seeing about the platform, it becomes more important to get to the level of the edge processing, where they can see like a real time health of the mining site. So the bigger impact that we want to create for the mining industry is where the production is optimized. If it's not optimized, how we can do it real time, get an alert to the site manager so that they can make a lot of not only production related decisions, but also how the compliance is structured, how the safety is structured, and giving them a real-time alerts about, this one of the areas if site is not maintained properly, they can quickly take actions. If there are 500 trucks which are moving in the site, and if we are constantly at the edge processing the data, streaming the data, and building analytics for them, instantly they can optimize the routes as well. So these are the things that we wish to kind of do in the future that currently the software is not doing.
What kind of mining or drilling environments are the most expensive because of the way they're done right now, and are the greatest need for this kind of software?
Yeah, so the mining, especially kind of drilling and blasting, it's an industry where that requires a lot of not only careful planning about what they're doing, but very accurate data. So if you see, it's a very this industry has not changed, and it's not about like they don't want to change. They don't want to adopt something which is going to create a problem for them. So the industry itself they are willing to adopt new technology. They're willing to change, but the change sometimes comes with a cost for them. So they've been using the same technology like laser scanners from last 20, 30 years, and they've become very comfortable with it. But it has its own set of limitations that comes along with it. And as the industry is moving forward, which is kind of industrial revolution 4.0, right? What we talk about, bringing AI, bringing computer vision, bringing a lot of IoT into play into the heavy industries. Those laser scanners basically are limited in those aspects that the data stays with it, but cannot be optimized or utilized to become better. So basically to make your mining smarter, to make your drilling and blasting smarter. So that's the kind of shift that we are making in this industry from not only from the drilling and blasting perspective, but overall mining.
Well, I just wondered, is underwater, drilling or explosions much harder than others? Underground mining, like the surface mining. Are there any scenarios that desperately need this work more than others?
Yeah. Currently, we are targeting open surface, mining. We are testing few use cases underground as well by utilizing different types of sensors on the computer vision side, like hyperspectral imagery and LiDAR imagery data. But that's still under the testing phase. But what we have developed for the drilling operations on the open surface mines that can be easily transferred to the underground as well. Only thing is the sensors, the data acquisition method will change.
Very good. So what's the best way for people to get in touch and to find out more about the computer vision you provide? To learn more about us, we visit our website is Strayos.com. We also have a lot of written more about the effective kind of how the computer vision and machine learning is impacting this industry in a whole. So there are a lot of blogs and articles out there that we have written. Also, we have lots, few white papers as well, which goes into much more technical items of this. So if anybody is interested, I'll be happy to share that, and you can reach out to my email ID, which is Ravi, RAVI, @Strayos.com. That's great, Ravi. It would be a bad joke if I said the conversation was a blast, but it was a good conversation. Very interesting. So I appreciate you coming.
Thank you.
You have been listening to Almost Here, Around the Corner Future Technology podcast with Richard Jacobs. Subscribe to this podcast, post a review to discover more future technologies that are poised to transform our lives for better or worse, such as Bitcoin, artificial intelligence, 3D printing, blockchain, virtual reality, and more.